Hello everyone, my name is Shirish Chavan from Group 5 and we are going to discuss the topic semantic analysis of text and natural language processing in software engineering. The general idea of our discussion here is now how natural language processing techniques can be leveraged to make phases in software development lifecycle easier and faster. So why NLP in software engineering? And why text analysis has been given such high priority in discussion. It has been found that natural language roughly constitutes 79% of the document. Also, textual information is easily understood by humans and is easy to make. Due to these reasons, if analyzed properly, NLP tools will provide great results. If we are able to directly automate the documents and artifacts, we could conclude we could get a feedback a little faster, which will consequently be more effective in getting desired results. Language conversion is a piece of cake using NLP, and due to this, outsourcing becomes easier and cheaper as the language barriers are broken. This also makes all the documents accessible to wider audience. So as we know that the traditional approaches bring in the problems in requirement gathering process such as incomplete and contradictory features which can also be ambiguous. NLP can help us get feedback on this faster and therefore take countermeasures quickly. So where can NLP help us? Pretty much in each phase. Like the previous example explained, it can help us in software requirement engineering, use case description and requirement validation. It also helps us in requirement traceability, which means whenever an NLP model reaches a conclusion, we can trace back to how it reached that conclusion. It also makes the testing phase faster, and this will also be discussed in detail later. These are some ideas presented in papers on how NLP can be applied to software engineering. If you have UML diagrams, you can use WordNet to convert them to natural language description. We can convert a controlled natural language text such as user stories into class diagrams. We can also convert natural language directly into UML or class diagram, which will be discussed later in detail. One upcoming application is where we can use video data to convert it into transcripts and then do semantic analysis on this data to get desired results.
Okay, so let's look at a few NLP basics. So how basically NLP works. So NLP can be broadly classified into syntax and semantics, which are the two parts of NLP. So syntax does several techniques such as lemmatization, part-of-speech tagging, stemming, etc. And on the semantics part, where we try to understand meaning from text, we can use several techniques such as ontology, word sense disambiguation, and named entity recognition. So this is a typical NLP workflow. So whenever you have a sentence, you can pre-process it using tokenization. In tokenization, the sentence is split into a number of words, and each word is assigned a part of speech tag, which is basically the property of the word. For example, it could be a noun, it could be an article, it could be a adjective, etc. After this process, we try to group the words together as entities, and we try to match them to concepts, probably using an ontology or a knowledge graph. After this process, we could figure out what the entity actually means. For example, it could be a place or it could be a person. So for this, we can use knowledge bases again to figure out what the semantics of the sentence is. And we can also normalize this process by trying to resolve ambiguities. For example, the same place could have different ways. There could be different ways of talking about the same place or the same thing. So here we can apply techniques such as word disambiguation. And we also try to figure out co-reference resolution. For example, we may be talking about a person, and in the next sentence we may refer to him as he instead of his actual name. And finally, we try to ground the entities that we discovered to external databases so that we can better understand what the sentence really means. So one aspect of NLP that's extensively used in requirement analysis is ontologies. An ontology is a specification for a concept. A concept could be something in a given domain, and it could have attributes, relationships, or even classes. And it could also extend other classes. For example, a person could be a class, and male could be an extension of person. And it could have several common attributes such as 2 hands, 2 legs, etc. RDF is the general language that is used to describe such concepts, in a formal specification. And querying in ontologies is basically done using a knowledge graph, usually an RDF graph, which is implemented using a query language called Sparkle. So ontologies basically have two parts. One is the description part and another is the reasoning part. In the description part, we have a set of concepts which are identified as entities, attributes, processes, etc. And the interrelationships between them are defined as edges in the graph. We also have a reasoning part, which gives us a logical understanding of the constraints between the entities, which we can use to verify whether two given entities are consistent or not. So the reason why ontologies are extensively used is because the description makes it easier to use conceptual inheritance. For example, the properties of human would be identified in subclasses such as male, female, etc. And reasoning in ontologies brings inferential capabilities that are not present in taxonomies used for modeling formally. And it makes it possible to search for contradictions that indicate inconsistencies, incompleteness, or ambiguity, etc. I don't think I did very well.
Often, a client may simply be unable to articulate the exact requirements and complexities of their job. Hence, the requirements document that they initially prepare will be technically incomplete. As a result, the requirements engineer will be unable to specify a system that adequately supports the job. So then the engineer prepares his version of the requirement specification, where he fills in the missing piece of information and conveys his understanding of what the stakeholders actually need. This back and forth activity of finalizing the requirement specification involves a lot of man hours spent in reviewing the documents. Now, this is where the NLP steps in. Employing NLP would reduce the number of man hours since the requirements documents submitted by the client and that of the engineer would be semantically compared. Please note that the comparison is carried out semantically and not lexicographically. To explain how NLP can be employed here, I need to get a little technical. I'll keep it simple and cover just the essentials. Generally, a pair of sentences or documents are considered to be similar if they have the same meaning or conveys the same idea or subject. In natural language, there are different meanings for a word, phrase, sentence, and document. Word is the smallest unit that holds a meaning, whereas sentence is the minimum unit to communicate a complete meaning. In natural languages, there are various levels of similarities like sentence similarity, document similarity, and so on. It should be noted that words are usually categorized into synonyms and antonyms depending on the similarity between words and phrases. The similarities between words in different sentences have great impact on the similarity between two sentences. So it is clear that words and their orders in the sentences are two chief factors to calculate sentence similarity. If words in two sentences are similar, then the two sentences are said to be similar. Likewise, if sentences in two documents are similar, then the two documents are said to be similar. The sentence similarity measure considers the relation between words. Going a little more technical here, generally documents are represented in the form of bag of words, while the meanings of documents are represented as vectors. The document similarity is calculated using the cosine of the vectors. Each word has a weight, and by ignoring this weight of the words, the document similarity can be measured based on the keyword set using dissimilarity or the checkered coefficient similarity. This application of NLP is already being employed in web searches, and its efficiency is improving every day.
Testing is a crucial part of any software lifecycle. It ensures that the developed product meets the need of the business. But creating test cases manually has many drawbacks. Test case design requires 40 to 70% of the software test lifecycle. Frequent changes in the requirement reduces the usability of the manually written test cases and costs more time and efforts to add those changes. The test cases written manually by inexperienced testers may not offer a complete coverage of the requirements. It adds high costs and resources for manually writing test cases. Test cases can be created from many sources, either from the requirement manual, SQL schema or databases, HTML or JSON schema, which are input and output of web services, UML diagram, which shows relationship between entities, design documents, or user stories created in agile process to explain the task concisely. The pipe and filter model can be used to generate test cases. Previously shown data can be ingested as the input to this model. Visual analysis can be performed on UML diagram, and structural analysis can be performed on JSON and XML schema to extract information. Then libraries like Stanford, NLP, and WordNet could be used to create graph that generate test cases. Bug detection. NLP can be used to extract words and find semantics of them. This can be linked with the programming code, test cases, and requirement manual and find the relationship between them. If any bug is detected, developer can be shown which section of the code he has to work and provides him description from the requirement manual and test cases for verification and validation purpose. System safety. Keywords and values can be extracted from the log files, and their meaning can be linked through NLP. This helps us to understand the condition of the system. Certain words like error, system down can be given higher priority while analyzing the text. Once detected, some notification could be sent to the concerned team through mail, Slack, or messages, depending on the criticality and the level of severity of the problem. Review and feedback plays a very important role after the product is launched in the market. It helps in understanding the user perception. It helps in understand how user is using the feature and what changes can be made to improve the feature. Sentimental text analysis can be performed to understand users' perception with the application. Feedback can also help us know features which are disturbing the user's experience and what problems users are facing in the application. This information can be used to plan the next development cycle.
Let's look at traceability using NLP and some of the applications in which it can be used. Traceability basically means understanding how the system came up with a particular inference. So it's a way of justifying whatever the system has predicted. It's a useful debugging technique since it gives us step-by-step analysis of the operation. It gives the user an ability to reason out different parts of the SDLC process. It gives genuine feedback for future learning if it is integrated with a model to heuristically learn from past mistakes to avoid them in the future. This would in turn improve the quality results over time as and when the system is used. And NLP can potentially play a very crucial role in automated generation of the RTM metrics, which is the requirements traceability metrics, which is a crucial part for traceability. Let's look at some of the applications of NLP. First would be generating UML diagrams from natural language specifications, and the second that we'll be talking about is semantic analysis for visual data. When we talk about generating UML diagrams from natural language, there's 4 key components. First of them is syntactic reconstruction, in which we break down the complex sentences that is provided by the user into simple sentences which can be further broken down into UML tokens. Second part would be verification to make sure that those sentences fall into the proper category of subject, predicate, and object, so that or the framework in which it should interpret that data, so that concept extraction can be done with using different NLP techniques like stemming, lemmatization, NER tagging, and the other features provided to us. Finally, we extract the class data, which would ultimately build the UML model. Next, we move on to the second application, which is semantic analysis for video data. The main feature that motivates this idea is that video data can be converted into transcripts, which can be further put into the mainstream framework in which we do the natural language processing and semantic analysis. So if we can build such an engine, we can auto-generate components like meeting minutes based on the video content. If a conference call can be recorded into a visual format, then it can save a lot of human intervention required to do these processes manually. Since we are saving a lot of human labor, they can be put into much more safety and time-critical SDLC applications. It also facilitates a framework in which we can score data to make sure that the accuracy is beyond a particular level that's expected. In a video, it's always easy for multiple people to collaborate. So so if multiple data points are obtained from a video, it can be segregated in a much more efficient and fast manner. It provides an all-encompassing view of the goal product, which means that we can get a full picture of what needs to be built before and itself.